Welcome to tutorial 14 on Core 3 Trigonometry. This is the fifth video in the series of Trigonometry for Core 3. Looking at the Edexcel Specification as always, what is highlighted in green is what we've done, and what we're going to do in this particular video is acquire the knowledge of two more identities and use those identities to do various things like simplify expressions and to solve equations. Let's begin straight away with the following. From Core 2, the following two identities came out. Cos squared theta plus sine squared theta is always 1, and tan theta is always sine theta over cos theta, where cos theta can't be 0. From Core 3, the following definitions or identities have come to play. Sec theta is 1 over cos theta, cosec theta is 1 over sine theta, and cot theta is cos theta over sine theta, i.e. it's 1 over tan theta. It's the flip of tan theta. Now, in Core 3, there are two new identities on top of this which we need to determine, and they are given to us here. Sec squared theta is 1 plus tan squared theta, and cosec squared theta is 1 plus cot squared theta. I'm going to show you how to derive them. You start with your most fundamental identity from Core 2. Cos squared theta plus sine squared theta is identical to 1. Imagine you took that and you divided every term by cos squared theta. Every term individually. You divided both sides of the equation by cos squared theta. Cos squared theta divided by cos squared theta would be 1. And you'd get sine squared theta divided by cos squared theta, and you get this is identical to 1 over cos squared theta. Okay? Now we can use some definitions from above. 1 is still 1. Now sine theta over cos theta is tan theta. So sine squared theta over cos squared theta must be tan squared theta. And 1 over cos theta is sec theta. So 1 over cos squared theta must be sec squared theta. And hence we have a new identity which we're going to use a lot. That is that sec squared theta is identical to 1 plus tan squared theta. Sec squared theta is identical to 1 plus tan squared theta. And we've got the first one. Now imagine we started off with the same very fundamental identity from Core 2, that cos squared theta plus sine squared theta is identical to 1. Can you guess what we do to get the other one? Well, we've divided by cos squared theta. Why don't we try and see what happens if we divide everything through by sine squared theta? Cos squared theta over sine squared theta, you get for the first term, plus sine squared theta over sine squared theta is 1, and you get this is equal to 1 over sine squared theta. Now we can use some of our definitions above. Cos theta over sine theta is cot theta. So cos squared theta over sine squared theta must be cot squared theta plus 1. And that's identical to 1 over sine squared theta. Well, 1 over sine theta is cosec theta. So 1 over sine squared theta must be cosec squared theta. And hence we have another identity which we're going to use throughout Core 3. And it's that cosec squared theta is 1 plus cot squared theta, or cot squared theta plus 1. Cosec squared theta is 1 plus cot squared theta. And we've derived those two identities. So just to summarize, you should be able to derive these. There is no real new knowledge here. As long as you know your cos squared theta plus sine squared theta is 1 and your definitions of tan, sec, cosec and cot, you get the other two for free by dividing by cos squared theta and by sine squared theta. So you don't have to memorize them, you can generate them each time. But just to summarize, here are the various identities which now need to be in our minds so that we can use them when required. So these are the Core 2 ones, the new Core 3 definitions, and two new Core 3 identities. Okay, let's just start by using them. We're going to go through all the same things we have to do previously. We're going to do some finding values of cos theta and sin theta using these definitions. We're then going to move on to some proving identities, and lastly we're going to solve some equations using these identities. What I'd encourage you to do in this video is pause each time I do an example and see if you can do it yourself using the new identities, and then work through with me and see if you got the right answer. Okay, I'm not going to get many examples for you to do yourself in this video. You know everything you need. I just encourage you, before I go through it, pause it, see if you can get it yourself. Okay, example 1, here we go. The first thing we're going to do is find trigonometric values given some particular trigonometric values and the identities. Now we are told that tan of an angle capital A is -5/12 and that A is obtuse. So what does that mean? A is obtuse means that A is between 90 and 180 degrees. Okay? Find sec theta and find find sec A and sine A. Right, we have tan of A. We want sec of A. Do we know an identity that has tan in it and sec in it? Well, we know this one does. We know, okay, an identity with tan and sec is as follows. 1 plus tan squared of A must be identical to sec squared of A. We've looked through all our identities and we found the one that has a tan and a sec in it, because that will help us find sec. So 1 plus, well, -5/12 squared must be identical to sec squared A. And we can work that out in our calculator. And when we work that out, we get ourselves that sec squared A must be equal to 169 over 144. And taking square roots of both sides, we find that sec A is one of two things. It's plus or minus 13 over 12. Now the question is here, which one is it? It tells us in the question that A is obtuse. Okay, so the way to do this, sec A, well, that comes from the cos A graph. So I always draw out cos A. Cos A looks something like this. Okay, and we know that A is obtuse, so it's bigger than 90. It's between 180 and 90. So the angle we're looking for is somewhere along this particular region here. Now that makes cos between 90 and 180, it makes cos negative. Okay, so in order, what sec do we want? Well, if cos is negative, sec's going to be negative for an obtuse angle. So the particular angle we're looking for here, therefore our answer, sec A, must be the -13/12. It can't be the positive 13/12. It's got to be the negative 13 over 12, because for an obtuse angle, cos is negative between 90 and 180, and that would also make sec negative. Hence, the answer for sec A is -13 over 12. Now, given we now know tan A and we know sec A, we want to find sine A. Okay, now by definition, we know the following. We know, is there any relationship between, can we get a tan and a sine in there? Well, we know from our core 2 relationship that tan A is the same thing as sine A over cos A. Okay, and we know from part A, if sec A is -13 over 12, well, cos A is the flip of that, it's -12 over 13, right? So therefore, if we want to find sine A, rearranging this formula, sine A must be equal to cos A times tan A. Okay, and we know cos A is -12 over 13. We know tan A is -5 over 12. So the answer we get for sine A is therefore equal to positive 5 over 13. Positive 5 over 13. And does that make sense? If A is an obtuse angle, well, does it make sense? Just a quick check. This isn't necessary here, but we'll just do a quick one. We know if that was the sine graph here, sine goes like this. Now for obtuse, we're looking between 90 and 180. And we know sine there is always positive there. So it makes sense that it's a positive number. Okay, so we're done in example 1. We have found other trig values using the some trig values given and the new identities we've learned. Okay, next. Here's example 2. We're going to try and prove an identity. I encourage you to take a second to pause the video and have a go, and then I'll go through. Okay, I'm going to start off with the left-hand side. I'm going to note that the left-hand side is the difference of two squares. Okay, so it's equal to cosec squared theta minus cot squared theta multiplied by cosec squared theta plus cot squared theta. Okay, so that was just a spot there that we were able to do. Now, do I know any identity that links cosec and cot? Well, from here, from this identity up here, you can say pretty clearly, if you subtract cot squared off both sides, that cosec squared theta minus cot squared theta is 1. So cosec squared theta minus cot squared theta is 1. So this is simply equal to 1 times this, which is cosec squared theta plus cot squared theta. Now, looking forward to what we're trying to show, we want cos squareds in the answer here. So the best thing to probably do is to, at this point, transfer back into sines and coses and see if we can get anything out of this. So this now, the definition of cosec is 1 over sine. So this is 1 over sine squared. And cot squared is cos squared over sine squared. Okay, and now we can add these fractions. They have the same denominator. So I'd get 1 plus cos squared theta over sine squared theta. And I've got the same numerators, which I'm happy about. And I'll remember from core 2 that sine squared theta is defined to be 1 minus cos squared theta. And I get myself the answer. 1 plus cos squared theta over 1 minus cos squared theta. And I have the right hand side, and I'm done. Okay, I'm going to try another identity. Pause the video, have a go, see if you can get the answer. Okay, going through then, let's see what we could do. Well, let's start on the left hand side. Okay, sec squared minus cos squared. So sec squared theta minus cos squared theta. Now, do we know any identity with sec squared in it? Well, we know sec squared is 1 plus tan squared. So let's just give it a go and see if that's any help. 1 plus tan squared theta minus cos squared theta. Okay, is that helpful? It's kind of helpful because the 1 here and the minus cos squared theta, 1 minus cos squared theta is sine squared theta. So this would give us sine squared theta, okay? And tan squared theta is by definition sine squared theta over cos squared theta. Okay, that's kind of that over 1 there. Now, if we factorise the sine squared out of it, because looking at our answer, we want a sine squared out the front. So if we factorised out sine squared theta, we would get 1 here, and we would get 1 over cos squared left, plus 1 over cos squared theta. Okay, and 1 over cos squared theta by definition is sec squared theta. So we get sine squared 1 plus sec squared theta, which is equal to the right hand side as required, and we're done. Okay, last thing we better do with these new identities is actually solve some trigonometric equations. So here is a very general problem that you might face a lot. Solve for theta in the interval 0 less than or equal to theta less than or equal to 360 the following. Pause the video, have a go. I'm going through in 10 seconds. Okay, right, looking at this now. We've got a trigonometric equation. It's got a cosec theta in it and a cot. Now, it's not going to be easy to solve when there are two different things going on. So it would be best to convert so they were all either in terms of cosec or cot. Now, looking at the identities we've got, we have a way of converting cosecs to cot squareds. And if I converted that cosec to a cot squared, everything would have cot squareds and cots in it, and you might be able to solve it. So I'm going to use the substitution cosec squared theta is cot squared theta plus 1 and substitute in. Let's give it a go. 4 cot squared theta plus 1 subtract 9 is going to be equal to cot theta. Now I'm going to expand the brackets. 4 cot squared theta plus 4 subtract 9 is going to be equal to cot theta. Now what I'm going to do, this 4 subtract 9, I'm going to combine those to -5, and I'm going to subtract cot theta off both sides. So I'm going to get 4 cot squared theta. I'm going to write my subtract or negative cot theta next, and my -5. That's equal to 0. Okay, now I have a quadratic in disguise. And we're going to give it a go at factorising. So I'm going to try 4 cot theta in that bracket, and I'm going to try cot theta in that bracket. And I've got to get myself numbers that multiply to -5. So why don't I try 1 here and -5 here, because -5 and the 1 times to give me the -5, and -5 cot theta plus 4 cot theta gives me the negative cot theta. Hence, I'm going to have two answers for cot theta. On the one hand, I'm going to have that 4 cot theta subtract 5 is 0, and over here on the other hand, I'm going to have cot theta is going to be equal, so cot theta plus 1 is going to equal 0. So solving for cot theta is therefore going to be equal to 5/4, and cot theta here is going to be equal to -1. Now what I'm going to do is I'm going to solve those. What I have to transfer back to tans here. If cot theta is 5/4, then tan theta is the reciprocal of this is 4/5. Similarly, if cot theta is -1, well, tan theta must be the reciprocal of -1, which is -1. Now I can find my principal value of theta. Theta is inverse tan 4/5 on the one hand, and you tap that in your calculator, keeping it in degrees mode. So you type inverse tan 4/5, and you get yourself 38.7 degrees. So that's 38.7 degrees. And if you do it over here, theta is the inverse tan of -1, and you get yourself -45 degrees. So theta is -45. Now, they're not the answers just as they are. We have to find the answers, any answers between 0 and 360. So as always, draw myself my graph to help me. Now remember, tan looks something like this. That's supposed to be 90. It's supposed to be 180. That's supposed to be 360. This here is 270. Okay, now I'm looking for when theta is 38.7 and other values. Now 38.7 is somewhere here. Okay, the other values that are going to be equal to it, I'm going to get 180 plus 38.7. So I'm going to get another value here for theta of 218.7, so 218.7 degrees. I'm going to highlight the values that are definitely answered. There's an answer and there's an answer. Now, theta is negative 45, is not in my range, but negative 45 is somewhere here. But I will get other answers where that's the answer. I'll get one there, and I'm going to get one here. It's 45 back from a root, so it's going to be 45 back from 180 and 45 back from 360. So theta is going to be 45 back from 180, which is 135, and it's going to be 45 back from 360, which is going to be equal to 315. And there are my 4 answers in the range I'm looking for that rather complicated equation. So state at the end that theta is equal to 38.7 degrees, 219 degrees if it was to 3 significant figures, let's say, 135 degrees and 315 degrees. And there I've shown you how the new 2 identities, which are up here, okay, and how to use them to find other trig values, to prove some further identities, and to solve more complicated equations. And there we're done. Now, to finish with, I'd encourage you to read chapter 6, page 93 to 97, work through those examples, and do the whole of exercise 6D as practice. Then have a look at the next video. Thank you very much for watching.